Hi, thanks for joining this talk. I want to thank USENIX and the LISA21 conference for giving me the opportunity to share with you some of the things that we're doing with Linkerd and to talk to you about service mesh in general. So with that, we can get started. My name is Charles. I am a field engineer at Buoyant, where we are the main sponsor for the Linkerd project, open source project. You can find me at all these wonderful places online. And if you have any questions for me, please drop me an email at charles@buoyant.io. So today, our agenda, we're going to talk about some service mesh concepts. For those of you who are not familiar with the service mesh, we'll give you a high-level overview of what it does, why it exists, why we even created it, and show you some of the problems that it solves. I'll talk specifically about Linkerd architecture. We'll do a demo to show you how it gets installed, how you get it up and running on your Kubernetes cluster in just minutes. And we'll have time to go over all of this stuff in a summary. So with that, let's jump right into it, the overview. So Service Mesh exists as a result of one of the teams inside of Twitter trying to solve the problem back in 2010 where uh, the Twitter had some stability issues. And so this came from the fact that there was a large monolithic application. And so the brilliant engineering team inside of Twitter decided, and if we're really going to solve this problem, what we need to do is break down this monolithic application into much smaller components into a distributed system. The problem is distributed systems are complex. When you have a monolithic application, it's basically a single process. You may have multiple instances of that single process, but if something goes wrong inside of that monolithic application, your logs, usually your logs or any other telemetry that you're collecting will tell you which piece of code you need to go and look at. Distributed systems are, again, much more complex because um, you've taken all of that logic out of one single process and put it into multiple separate processes that are connected through a network. And so um, now processes that were previously communicating through procedure calls inside of a single process, or functions, I should say, are now communicating across the network where things can magically disappear or the latency can cause issues within the code itself that you may not have anticipated when the code was written. So a service mesh uses the network of a distributed system to observe, secure, and add reliability to that application, to that distributed system or application. I'll use system and application interchangeably in this talk, but so that way you're not confused. So the value of the service mesh is it's taking all of these different pieces that are communicating with each other and giving you insight into how they're communicating with each other. If there's a problem with any one part of the application or any one of the pieces of the application, such that your team can go and track down the issue quickly and resolve the issue. So one of the main problems that the service mesh solves is mean time to detection and mean time to resolution of errors, which is very powerful. Let's take a look at the architecture of a service mesh, specifically the Linkerd service mesh, which is the open source project that I'm a part of. It consists of a data plane and a control plane. The data plane consists of many proxies that are injected into your workloads, your services. These proxies, and that's one of the powerful pieces, is this automatic proxy injection. So in the demo, you'll see me add an annotation to a namespace, a Kubernetes resource. And what that will do is it will trigger Linkerd, the control plane, which we'll talk about next, to automatically inject the code for this proxy, the YAML, I should say, for this proxy into the service so that when the workload starts up, the proxy is in there and it's configured to handle all of the traffic to the service. So to think of this another way, when we look back at this slide, we've got services that are communicating directly with each other inside of a distributed system that doesn't have a service mesh. With the data plane, we've got these sidecar proxies, which are now handling all the traffic. So the services themselves aren't communicating with each other. In fact, the proxies are communicating with each other and then sending that traffic to the service on what is effectively localhost inside of the workload. So this opens up a lot of powerful options, as you can imagine. Anything that's handling the traffic between two services is then has access to specifically things like telemetry. You can understand the latency between two services. When service one sends a request to service two, the proxy knows exactly when the request was sent from service one and when the response was received from service two. And that's the simplest way to capture latency. One of the other things that Linkerd will do is it provides mutual TLS, and we'll talk about that in an upcoming slide. Mutual TLS is really powerful for a number of reasons, but the takeaway right now is that your engineers, your developers of these services, don't have to instrument their code with logic to build mutual TLS on their own. Instead, they can make simple plain text requests from services within a cluster, and the proxies will then take those plain text requests, uh, translate them, or not translate them, but wrap them in mutual TLS and send those requests across. So if there is a bad actor on the network or anybody on the network, really, they will only see that encrypted traffic. So it's really powerful. And another thing that the proxies allow for is load balancing. So again, if you've got direct service-to-service communication, service one doesn't necessarily know how many workloads there are behind service two or how many instances there are. So if you've got 10 instances of service two and service one is sending a request, it doesn't know which workload is going to respond the fastest. And what our proxies do is that they capture the metrics, the response latencies, and we use an algorithm called estimated weighted moving average, which then determines the right instance of a workload to send that traffic to. So that's kind of in the weeds. It's a very powerful algorithm, and it's been around for a long time. You'll see it in a lot of web servers. The idea is to use past performance to try and properly detect which instance of a workload is going to again respond the fastest. So this is much better than round robin load balancing and provides for much more reliable and robust application. And since these proxies are handling traffic, they can also inspect the responses and allow for retries and timeouts from the proxy side. So again, your service, your engineers writing that service code can focus on what the service has to do and not worry about some of the mundane tasks like retries and timeouts, which are actually tricky to implement properly. So that's the data plane. A number of proxies injected into your workloads, handling traffic all across the network. The control plane is a finite set of components. And in the Linkerd control plane, we've got the identity service, the destination service, the proxy injector, which is the logic that will detect which workloads should have the proxies injected into them. And we've got the controller, which provides API endpoints. All of these components are used to configure a new proxy that is added to the data plane. So in a very simple path, what happens is when a new workload is provisioned, the proxy injector checks to see if the proxy should be injected into the service. If so, then the YAML is generated for that proxy. It gets its configuration from the destination and identity services, and those are the destination services for service discovery. So it tells us what other workloads are available and when that load balancing or when those requests are sent from this new service that's being created, what those destination endpoints that are available. The identity service is what's used to create the mutual TLS certificates that the proxies use to communicate with each other. So again, The control plane is a finite set of components that are used to configure the proxies that are injected into the services which are in the data plane. So you've got a clear line of separation between those two. And so that's the high level overview of the architecture of Linkerd. And to be fair, this is a fairly common pattern for service mesh architectures. I touched on some of the service mesh concepts already, but let's dive into them a little bit more and see if, just to get more detail on what the service mesh provides and what problems it solves. So I talked about mutual TLS. What this is that identity component that I showed you in the control plane. It has a trust root in it, and it's a certificate that is used, sorry, it's a certificate issuer. And so when a new proxy is created, it sends a certificate signing request to the identity service, which then signs that certificate and sends it back to the proxy. And then when one proxy communicates with another proxy, the first thing that they do is they verify that they are who they say they are, their identity is unique, and it's issued by that same identity service. So you've got a common trust source that issues certificates to these services that are going to communicate with each other. And when those two services can verify that they are who they say they are, then they can begin to communicate with each other over encrypted traffic. So I want to be explicit about that because mutual TLS it's very easy to think about it as I'm automatically getting encryption between my two services. That's just TLS. Mutual TLS adds that verification piece, which is really important, especially if you're in a multi-tenant environment where it's entirely possible that you could have multiple users using a service mesh like Linkerd. And if some of their workloads try to communicate with each other, you need to make sure that the credentials that have been issued, those certificates, are coming from the same source. And that's really powerful, and it's really important for a secure environment. A lot of the folks in the Linkerd community who are in businesses that require end-to-end encryption find this very, very powerful. So end-to-end encryption is required in some in industries by regulation and others just by requirement. So telecoms is a really common industry where you see end-to-end encryption required. And so with this Linkerd mutual TLS, the developers of the services don't have to worry about building that. The Linkerd proxies will build that end-to-end encryption, or sorry, the mutual TLS, which then becomes a part of the end-to-end encryption. So that's the security aspect of what a service mesh offers, what Linkerd offers. There are a couple of components to the observability piece. And so observability has become a pretty popular term for something that we've been using all been using for a very long time for monitoring. But in my opinion, observability goes deeper than monitoring. Observability, monitoring tells you what's going on from a high level. For me, observability gives you actionable data, actionable metrics that you can then use to, as I mentioned, reduce that mean time to detection and mean time to recovery for any issues that come up. So with these proxies in place, as I mentioned, if service 1 is talking to service 2, service 1 knows when it sent the request to service 2 and when it gets the response back. That measures the latency between those two. It also allows for measuring the request per second and the error and success rates. And these are three of the main components for what the Google SRE book calls the golden metrics. So here I've got a screenshot of what I'll show you during the demo is the actual request per second, real-time request per second, and the P50, P95, and P99 latencies for some gRPC traffic that is going between services in a demo application that I'll set up. Another part of observability that Linkerd offers is the service topology. And this is pretty simple. In our demo, we'll see that we've got 4 workloads. 3 of them are services, and 1 is a request generator. And in this simple diagram, what we see is that um, one we see the way that the services are connected to each other. We call these edges in Linkerd. So there are edges between voting and web and emoji and web, and there also is an edge between VoteBot and web. So VoteBot is the generator that's sending requests, and the web service is then sending traffic to voting and emoji. This is a screenshot from the dashboard that I'll show you. This will make a little bit more sense when we look at the dashboard itself. And the interesting thing is that Linkerd itself uses Linkerd, so we can look at the control plane components and how they all relate to each other as well. It'll be fun. We'll take a look at that. The last piece that Service Mesh offers, or one of the main concepts, is reliability. And for us, that means load balancing, retries, and timeouts. And the load balancing is really important. Oftentimes, well, so for an application to remain reliable, we want to make sure that um, all of the workloads for within the application are getting an even amount of traffic. So a really simple way to think about this is in this diagram here. We've got service A talking to multiple instances of service B. We've got B1, B2, B3. We see that the latency for B1 and B2 is 20 milliseconds or greater. This is all just an example. And we see that the latency for B3 is at 18 milliseconds. So the load balancer inside of Service A, the proxy that uses that EWMA algorithm that I mentioned, is going to send the next request to B3 because it's got the lowest latency based off of those latency buckets that I showed you in that screenshot. And so this can be changing all the time, and this definitely changes all the time, I should say, because if B3 is currently has the lowest estimated latency, if you keep sending requests to it, its latency is going to go higher while the other two drop. And so a smart load balancer will recognize that the other two are dropping and begin to load balance requests across those. So what you hope to see is an even distribution or a very small deviation between the amount of latency between for each of the services or each of the instances of the service. So those are the main concepts. We've got observability, security, and reliability. If we have time, I'll get into the retries and timeouts. One of the things that we will do is I'll show you the per route metrics that we can configure in Linkerd. So with that, why don't we jump straight into the demo? Okay, so I'm running a Kubernetes cluster locally. So if I look at all the pods in my cluster, I can see that the cluster, I just started this 29 minutes ago. This is a K3D cluster. It's meant for running locally here, but you can run K3D in production as well. The first thing that I'm going to do is deploy that application that I mentioned to you. So let me grab a link over here. This is called Emojivoto. It's a gRPC application that we use for demonstrating Linkerd's gRPC load balancing ability. So Linkerd will load balance HTTP and gRPC. gRPC is a little bit more difficult to load balance because it's a connection-based protocol. So let's create this application. Oops. Huh. Okay. Oh, I know why. It's the wrong one. Okay. This is available at run.linkerd.io, where you can install Linkerd, the Linkerd CLI, which I'm using. You'll see me use. I've already got it installed, and also our demo applications are available there as well. So you'll see that I created a namespace, some service accounts, and some deployments. So if we look, change our namespace to Emojivoto and look at the pods there, we can see that those containers are creating. You'll notice those names look similar to the diagrams that I showed you. We've got web, votebot, voting, and emoji. So we'll let those start up. And while that's happening, I'll show you some features of the Linkerd CLI before we install it. The first thing we want to do before we deploy the Linkerd control plane, which is what we call installing Linkerd, is check to make sure that we can install it in the cluster. So this Linkerd check -- pre is a pre-flight check, and we can see that everything in Kubernetes is okay. We have the right permissions, so we can just go ahead and install it. The Linkerd install command will generate the YAML for you, but it won't apply that YAML. We have to pipe it directly to kube control apply. Once we do that, we can see that all of the resources are created. Those are deployments, service accounts, some RBAC pieces. There's only there are two custom resource descriptions in Linkerd as of this recording. So we can do Linkerd check without the pre-flag now, and that's going to go through and check to make sure that the control plane is up and running. I know that it's taking a second to run because my machine's a little bit slow. So another thing we can do is just look at the components or the workloads inside of the Linkerd namespace. And so we see those control plane components that I mentioned earlier, controller, destination, identity, and proxy injector. So we'll let this continue to start. Once it is up and running, what we'll see is that the application is not yet part of the mesh. And so these are the core control plane components. What we're also going to do is install the Linkerd viz components. So that's the visualization. This gives us some command line interfaces for getting telemetry out of our application, as well as a dashboard that includes Prometheus and Grafana. So let's look at, again, the resources in the Linkerd, or the workloads in the Linkerd namespace. Before we install the viz extension, I'm going to annotate the emoji voto namespace with linkerd.io. Actually, first let's look at the pods in emoji voto. The important thing to take away here is that we see that there's one container in each pod, and that's it. It's running, and so that's the service itself. We're going to annotate the emoji voto namespace with Linkerd inject enabled. Once that's annotated, I can do a restart of the deployments in that emoji voto namespace. And we can watch these start up, and immediately we see that there are 2 of 2 pods running there. And so if we dive into that, what we can see is, let's get one of these. We'll do kube control get pod, JSON, and I think it's jq.spec.containers.name. Okay, we see the web service. Oh, that's an old pod, that's why. We want one of these new pods. So let's look at this pod here, the emoji pod that was just started with the proxy injected. And we can see that we've got a Linkerd proxy injected in there. That's part of the data plane that I mentioned earlier. We can also look at the init containers and see that there's a Linkerd init in there. And that configures the firewall rules so that the proxy can manage that traffic that's coming in and out of the pod. So now this emoji voto application is part of our service mesh. We can visualize that using Linkerd viz. Again, there's Linkerd viz install. This is an extension with some more control components that are added to the control plane. And we see that it's going to generate a bunch of YAML. I have to actually apply that. So one of the designs of Linkerd is to not be intrusive. And so you have to explicitly say that you want these things to be installed before they will be deployed to the application or to the cluster. So now we can do, if we look at the pods in Linkerd Viz, which is the namespace, we can see that some of them are up and running. One of the things I wanted to show you, if we look in the Linkerd namespace for the control plane, we can see, again, we've got two pods there. So like I said, Linkerd runs Linkerd. It's super cool. So if we take a look at the control plane, let's do Linkerd. Actually, let's make sure those pods are up and running. Oops. Yes, great. Okay, so this. Great. Okay, so now we can do Linkerd Dashboard, and that will show us this UI. So let me make this a little bit bigger so you can see it. This is the Linkerd Dashboard. We can see we've got our emoji Voto namespace there, and this is where we can begin to see how things have been added to the mesh. We see those 4 workloads that I showed you. This looks exactly like the slide that I showed you earlier, which is kind of not interesting, kind of by design. I cheated there. But let's go and take a look at the Linkerd namespace or Linkerd Viz namespace, and we'll be able to see how some of these other components are communicating with each other. So in the Viz namespace, we see that Prometheus is scraping all of these components for their metrics, and that's where all of this great information is coming from. We can see the requests per second, the latencies, the success rates. So this is exactly what we expect to see. Again, in the Linkerd namespace, we're not seeing the service topology, but we're seeing each of the components there, and we see that they are part of the mesh as well. So a fun thing that I like to do is we can, let's edit the emoji Voto namespace, and we'll take away this. We'll turn off the injection, and you'll actually see how quickly Linkerd will pick this up once we restart the deployments. So as soon as this, what I've done is taken the proxy out. So if we look at the pods, we'll see that there's 1 of 1 and all of the new pods that are starting up. And all of a sudden we've lost this information. This is all historic information. We're not seeing the current information of the telemetry for the pods in emoji Voto. So this all happens very quickly, which is why I show that. So let's go back and we'll set that to enabled again. And we'll do the restart. And almost straight away, we see that the pods that are starting up are injected with Linkerd, and we'll start getting that telemetry from them. Everything in the dashboard that we see here comes from the telemetry that's collected in the Prometheus instance that comes with Linkerd Viz. This is provided by the controller instance of the control plane. So the Linkerd CLI also gives us the same information just on a command line format. So if I do Linkerd Viz stat of the pods inside of emoji Voto, what we will see is that same telemetry that we see in the dashboard, but in a CLI interface. And so this allows us to use CI tools to integrate with Linkerd so that we can see exactly what's happening and we can integrate other tools as well. So we see that there's some failures. That's a built-in failure. That's, again, part of the demonstration, part of the application. The last thing I want to show you, though, is this routes feature. And this is where we talked about getting per route metrics. So right now, if I go into the web component, we see that if I look at the route metrics, we can see that there's just the default route, which is basically slash. And if I look at the same thing here in the terminal, I will see there's just the default route. What I'm going to do is apply that file that I attempted to apply before, and this is our web service profile. And this just defines a service profile that lets us specify each of the routes for this web service. And again, immediately we see that those routes are picked up, and as soon as the information is collected in Prometheus, the dashboard will display it. And so we can see that same information again in the terminal here. So as we watch this traffic go through, we'll see success and error rates. The vote error rate will go up eventually, but there will be success rate will go up, but we know that there are errors baked in there. So that is the per route metrics, and inside of the service profiles is where we can configure the retries and timeouts that I mentioned as part of the reliability piece. So with that, we can jump back over to our slides here. That was the demo. This is the summary. We talked about the concepts of a service mesh. We talked about the overview of the service mesh, why it exists, why Linkerd exists, where Linkerd came from, and the problems that it solves. And we've got a great community that, if you're interested, check them out. We are on slack.linkerd.io, and all these folks here are users of Linkerd. They have deployed applications and have solved issues, solved problems, have gained real value from using Linkerd as a service mesh. So again, I want to thank LISA21 for having me. And if you have any questions, please reach out to me. I'm Charles at buoyant.io. Thanks a lot.